I've known David for quite a few years at this point, and I always think that the last thing he's shown me was the last time he's going to give me an aha. It just doesn't happen. Every time that he comes up with something new and exciting and shows me, it kind of blows me away. And you'll see two evidence of that in this presentation, and more if you haven't seen his prior work. But he's taken what we can do in 2D on the laser and given it that third dimension and produced some stunning results. So I think we're very fortunate to have David, and really appreciate you doing this.
Hi, so I'm David, and I spent 7 or 8 shop slots in the last month preparing for this to give you lots of examples. So let's get started. I'm going to go through with some fundamentals first. So to use Lightburn, you've definitely seen this menu for the cut settings. And there's a drop down for the image mode that has all sorts of options. And it works out such that almost all of them, besides grayscale, are what you'd consider an on-off. So the laser is either firing at whatever power you set it to, or it's off. And in order to show you something that looks like grayscale, it dithers. So it kind of does like what a newspaper looks like, with more dots for dark and less for light. But when you use grayscale, it's actually variable power. So as the laser is going across, it modulates how much power is going through so that it'll burn darker, the higher power, and deeper, and then less deep at a lower power. And this presentation is all going to be about grayscale. So there's 4 parameters we care about for this. The top 3 are ones you're probably already very familiar with. You've got speed, that's how fast the head's moving across the piece. You have max power, and that's going to be the power that it uses to burn black pixels. And min power is the power that it uses to burn the white pixels. And in between, it will scale it linearly to set the power for each pixel in the image. The 4th one, though, is line interval. And this is how close the lines are as it goes back and forth, as it moves in the y-axis. And the obvious thing is that's the separation of lines, but it has another side point that it's also the width of each pixel. And this is only really evident if you make it ridiculously large line interval, because then you'll see that your images become incredibly pixelated across the line as well. So those are the parameters we care about, and the rest of the presentation is going to have these on basically every slide. If there's any questions, we should go over it now.
So, Dave, I see 255, levels. But what are our systems actually capable of? How many levels can you actually achieve?
All of them.
Oh, really? Wow. Okay.
In fact, having looked at the output that it's sending to the laser, it's not actually sending the 0 to 55. I think it's actually a 16-bit value. So you could probably actually do more than the 8 bits. But I don't have a good way of testing that.
Right.
All right, so this is very wordy, but basically for those 4 parameters, they each impact the depth of burn in different ways. So if you decrease the speed, it's going to make it burn deeper everywhere. If you increase the max power, it's going to increase the depth of the dark areas. If you increase the min power, it will increase the depth of the white areas. And decreasing the line interval makes it burn deeper everywhere. So the basic impact of this is that changing any of these parameters will affect the depth in a certain way, and they all kind of work together.
David, did you say that changing the line interval, like increasing the line interval, was going to increase depth?
Reducing the line.
Reducing, that's what I thought.
Yeah, smaller line interval, the closer they are together. It's basically like you're mowing a yard and you have to overlap each line a little bit.
Yeah.
So you overscan. So this is basically how much you want to overscan. All right, so throughout all of this, my goal was to get the maximum depth of burn possible, where not necessarily the depth of burn, but the difference between the black and the white. So the highest and lowest you can get. I want to maximize that. So the intuition would be you want to set the speed so that it's as low as you can go until it starts burning uncontrollably. You want the max power at 100%, and theoretically you'd think min power of 0%. I want the laser off when it's white. And the line interval you'd set to be the size of the laser dot, theoretically, so you don't have any unnecessary overlap. And you would think that this would give you great results. Unfortunately, physics and mechanics of the laser cause problems. So, a quick summary of some of the findings. I found a speed of 150 millimeters a second was good, and going slower than that, as we'll see, had some unnecessary burning, and 100% max is fine. 0% min doesn't work though, and that's because the laser doesn't fire until it gets to a certain minimum level, and on the Nova 35, that's 4%. So if you have anything less than 4%, the lasers won't turn on, doesn't matter what the image is. So that way, 4 is actually the minimum you could ever really use for engraving. And if you use that, you'll get the maximum possible depth range. But there's some nonlinearity and artifacts that you get from that, and practically 37% will give you the most accurate result. We'll go into why that works out later. And then for line interval, changing it from the 0.1 to 0.05 or 0.03 gives you good results. So that's fine.
Did you, on the same on both systems now, or is there differences between the two?
So I did all the testing on the Nova 35, or yeah, the Nova 35, except for 2 burns of the 51. We'll get into that later. But there are differences. So the turn-on power of the 51 is 6% instead of 4. And the point at which linearity gets better is 20% instead of 37. But there's other problems with the 51, so we'll get to that later. Very good presentation.
When you said 37% was a good minimum, because it's at that point you really started to get more of a linear relationship between, and prior to that it was not on line with, say, 37% to 100%. It was like more steep or more shallow. Or...
I've got pictures of it later.
Great.
To show it all off.
Great, thanks.
I just wanted to show where we're going here. So we're going to see a whole lot of these. This is basically the image that's burned, that I've burned more than anything else. This is my grayscale calibration image that I designed. And the general idea here is you've got a 16 by 16 grid of each possible grayscale value. And when there's tick marks on the outside so that you can figure out what any given point in there, what color it was, if you want to. And I've got 2 versions of it. This was the original, and I had to make this one because Lightburn, I think around version 0.9, switched the way it handles grayscale engraving such that before, white meant laser off, but now white means min power. And the only way to get the laser to turn off when you're doing grayscale is to use transparency, which is its own problematic point. I don't know of an easier way to do it. I do it in Photoshop with layers. So if you want to have it, the laser turn off when you're doing grayscale engraving, you have to use transparent pixels. And those are the images we have. So then we're going to see a whole lot of those. So this is the nonlinearity I was talking about. So this was using the parameters where you've got 100% to 4% and 0.05 line interval. And this is showing that in this section up here, it is not a smooth gradient. So because the test image is very smooth, it's got all the shades and they all blend nicely, you would expect that the output is nice and smooth. But in fact it is not, and it's got all these weird undulations that happen at different power levels. And I found that if you pick the point right there, that's 37% power. And if you use that instead for the min, you get the result on the right, which is a nice smooth gradient. And that's basically the settings I've used for almost all of the engravings here. And it works great for giving results that are accurate, but as you can see, you've wasted all this material at the top. So you're basically losing a third of the cut just to waste in order to achieve the linearity you want. So that's the first point. The second one is what I would call scalloping. And the difference between these is a transparent versus white border. They both use 4% min power. And this is showing that laser is fully capable of having nice sharp edges on the back. But when I did it, I saw this weird scalloping. And this was a huge headache that shouldn't have happened. And I spent a lot of time trying to figure out what was going wrong.
I'm not sure there's people that necessarily understand the scalloping, because it wasn't obvious to me when we first talked about this, but it's the rounding.
Yeah, up here.
It's the rounding around all on the back.
Yeah,
as
so
opposed
it
to
should
sharp
be
corners.
nice and sharp, but it's not. And the only difference between these was that in here, this is transparent, so the laser's off, and over there, it's white, where it's 4%. So you would expect it to just be just barely burned, if any at all. But it's got this weird undulation. And I tried all sorts of things to figure out what was going wrong, including disabling the bidirectional scanning, reducing the acceleration on the machine itself, and changing power levels.
And did these pictures, these are straight off the laser, or do you do any cleanup?
This is after extensive cleanup.
Oh.
Yeah, I've got a picture later of what it looks like straight off the laser. So this was one of the first tests. The only difference between these is that this one has bidirectional scanning on, and that has it off. And the difference that normally when you do the laser, it goes across one way, it's cutting, goes back the other way, it's still cutting. When you turn off bidirectional scanning, it only cuts in one direction. And then it just quickly goes back and then cuts again. So you can see that the scallop went from being fully scalloped to being half scalloped. So this half fixed the problem. And the conclusion I got from this was that the issue happens as the laser's going across, it transitions from high power to low power, and it just can't do it fast enough. So it keeps burning at a little bit too high a power for too long. And you can see that happening here, where we go from light to dark, it's fine, a nice transition. But when you go from dark to light, you get this kind of sweep that comes up. So the end result was if you use the 4% min power, your geometry is going to get rounded off in the high spots, more or less. And I don't know any way around that besides picking a higher min power level. So that's what this is at.
I'm sorry, is this part of how you concluded you ended up doing all this stuff at 37% min power, and you couldn't get the results you wanted with anything less than 30% min power, and you were trying to get the maximum overall height of an object, so you attempted to go to lower min power, but you couldn't.
So I wanted to have the largest range,
Yeah.
which would be using the 4% min power.
Yeah.
But then I found using that has two problems. The first is that you have this nonlinearity where the lowest powers are not giving you a consistent result in terms of depth output. Theoretically, if that is totally consistent, which I don't think it is, you could figure out exactly what those depths are and do a transform of your image in Photoshop with a transfer function and somehow get your output to look right. Maybe. But even if you could do that, you will not be able to overcome this problem. Because this is basically the machine itself. The controller isn't able to, I guess, get rid of the current that is pushing through the laser tube fast enough to go to low power quickly. So I don't think there's a way to overcome this.
And at 37%, you wouldn't have seen the scallops?
Yes, that's the next slide. So this is showing 4% versus 37. And you can see that we go from having the scallops to not having the scallops. So you get a nice sharp edge.
Yeah.
So this is basically the using 37 solves the nonlinearity and solves this scalloping issue. But you can see that since this is the white, all of the area between the top of the wood and that is just burned away across the entire image. So that's the trade-off for getting this improved geometry output.
So that's what you said your limit is about 2 millimeters, is that what you end up with?
So the distance between the white and the bottom where the black is like 3.1 millimeters. And you lose like 1.6, I think, between the top of the wood and where the white's at. So your total depth at the deepest part's like 5.6 millimeters.
With a 2-inch lens? Is it
This is
with
all-
the
the
installed
default
2-inch lens?
I have not tried the 2.5 yet.
Okay.
But theoretically, that should give you more depth,
Right.
and we'll see. That had to be a whole other test.
Yeah.
All right. So then I suppose I can start passing these out just so you can see them. So here's some of the grayscale ones. And there's another. So this was this piece here, testing a bunch of things. So this is the one time I had done the grayscale squares smaller because this was just a scrap from the scrap bin, and that's how wide it was. So I tried various different settings, and the most exciting are the last two. Those are 100 millimeters a second, 125. And those are the ones where if you look closely, you can see on the back edge that the burning was uncommanded. And that's going to ruin your design, so that's too slow. Besides being dangerous. And then the 0.05 versus 0.03 for the line interval, both seem to give good results. The 0.03 is going to get you deeper, but it has a rougher texture in the lower parts. So that's all those are at.
And type of wood? Is this all the same type of wood?
So almost all of this is done on maple.
Okay.
I would definitely recommend maple. It works great. And
Not to mention you did have to redo all this for all the different ones.
Yeah.
well, I did do. I also used walnut, mahogany, and acrylic. We'll get into those later. So here's some actual non-test images. So this is showing a situation where the non-linearity you get from using the 4% min power is not a problem. If you've got a design where it doesn't matter if it's exactly the right geometry, you can get that full range. And you can see that it has a dramatic impact where you've got this very clear texture compared to much lower for the one on the right. So this is a situation where using the 4% works out great.
So David,
Yeah.
the non-conformity based on 4% versus 30%. I was looking up there and I'm looking at this and I was looking at this and saying, well, this must be one of those 4% burns because it's got all these ripples in it.
That's
Then I
a good
look
problem.
and it says, no, it's 37%. So what are those ripples?
That's from the Nova 51. I'll get to that later.
Okay, thanks. Gotcha.
Yeah, unfortunately that piece has Nova 35 on one side and 51 on the other.
Okay, I just,
David, just because people may not have seen that before, I just want to clarify. What you're seeing up there on the left-hand side, the little square, the far left-hand side, is the image that he was using to create those two. And so the idea that dark is deeper and light is shallower, can be seen in that, and the two different representations are on the right. I'm not sure that I caught in the beginning you were using that image on the left. I just want people to be aware that that
yeah,
was
that's
the source.
good clarification.
Yeah. Yeah, that's exactly right. Then here's another illustration of some design impacts. So this was the image that was burned on all three of these. It's a set of chains, and because at a given combination of settings, the depth of burn is fixed, so the 5.6 millimeters, for instance, you can change the visual impact of the final object significantly just by its size. So this one doesn't look like chains. That one pretty much looks like chains, maybe a little too tall. That one's kind of flat. And the only difference was the physical size. Now, and the big one used a different min power, but that just makes it a little more shallow.
So in other words, you have a fixed Z.
Yeah, you've got a fixed thickness you can make it. So if you scale it bigger, it's going to make everything look flatter. And for some things, it's not a problem. If you've got an image where it's got a whole lot of small details, you can probably scale it up pretty well. But if it's something like a face where it's really smooth gradients, it's not going to work out. Make it bigger. And this is just kind of illustrating it.
So is this the piece that you said was a chain but didn't look like a chain?
Yes, if you look at it straight on, it kind of looks like a chain, but if you look at it just a bit tilted,
Yeah.
it's totally wrong. And that's just the impact of changing the physical size.
Got it.
So it's not like a CNC where you can just say, I want to make it bigger, and it's going to cut deeper for the bigger ones, and it will still be the same aspect ratio. When you do it with laser, you're a fixed thickness. So You have to keep that in mind if you want a certain geometry on the output. So now we get to more fun artistic things. So this is showing what it looks like straight off the laser, which is that it's really hard to photograph too because it's just jet black. It's a black mess. And it's super sticky. I would recommend gloves. It's going to stain your hands. Yeah, it's fun. So,
What is the process you use for cleaning it?
so I take a toothbrush and running water and just scrub it.
Okay.
And then put a couple of drops of dish soap on the toothbrush too. I don't want to use too much soap because I don't want it to soak in, but
Yeah.
just enough that it gets off whatever's not loose. Surprisingly, just the rinse gets a lot of it off. Some of it's just like a powder that's barely stuck to a sticky layer underneath. But yeah, so it's quite dark when it comes off the laser.
David,
Yeah.
how do you select that starting image and how do you get to that image?
So this one was from Google. I just found
But that's the way you downloaded it?
Yeah. So it looked, well,
Lou, this is something you could do.
yeah. So it looked basically like this. But the main thing I had changed.
What's Google?
Yeah. The main thing I had changed in this was that the image was a square, solid black square, and I didn't want to engrave a square.
So what
in
are you looking for in that image?
What am I looking for?
Yeah, he's asking us similar to what I've asked you
Oh.
before, David. What are you specifically looking at in the image to make a decision, or what you might want to change in your PhotoCarve software or your Adobe Photoshop, whatever you're using? What are you focused on in that image to try to get to that end result that you're trying to get at?
The only thing I changed in this was cutting out the outside. So
But in general, what would you be looking for?
I mean, in general, I just download it and use it. So trying to modify it, it's gonna likely lead to less good results, let's say. I mean, you can do some things. So
But you're looking for darkness versus lightness and recognizing, this is what I got from you, so I'm not putting words in your mouth, I want you to
I mean, you have to
share it. What I'm looking for, based on what you told me, and I can't do any of this stuff yet, I'm still struggling with it, like you said, is I was looking for darkness, meaning black means it's going to go as deep, and then a gradient out to where it's going to be higher, so that in the end it should look, the
Yeah.
depth should be based on that color gradient.
Yeah, so this image is not a general purpose image. This was specifically generated by somebody from a 3D model to be a depth map. So you have to use a depth map. You can't just use any image. And
Okay,
then
that's the answer.
it's a specially created image.
It's a 3D model.
So when you do it in Google, you're searching for depth map.
Right.
Yeah,
Right.
yeah, I've got a slide on it later too.
Okay,
Look at that.
And this was not touched by Photoshop.
This
This
was.
is-
The only thing I
oh.
changed was to cut out the outside. Before it was a black square, and I
Yes.
didn't want to engrave all
Right,
black.
right.
So I just cut it out and made it transparent.
But no other image editing properties. It was
I
then
think it
taken
sharpened
into
it a bit,
Lightburn.
but besides that, I don't think there was much
But in Lightburn, what file types will it take?
in any image.
Any
So
image.
JPEG, PNG, but whatever. But yeah, I mean, this is just a normal image file, but creating it required a special process.
I just gotta hand it to you, when you look at these things you're passing around, the tenacity and the ability to see beyond the char.
Oh yeah.
Because I would have given up, I just ruined that one, you know. So that gives hope to, when you're burning things, it may not be what you think it is until you do these extra steps that you're gonna get into.
Yeah. Yeah, in fact, for that point, when it comes out, that layer of goo can be quite thick.
Yeah.
It can be filling in most of the image. You look at it, you're like, oh my God, it's terrible. And then you just gotta wait till you clean
I
it.
wonder how many masterpieces I threw away.
Turns out all we need is dish soap.
Are you using multiple passes?
This is all done with one pass.
Have you tried using multiple?
I have not, only because, so the question is this one pass or more? And these are all done in one pass. And the reason I do that is because when you start with the stock, it's perfectly smooth and flat and clean and consistent throughout its entire depth. So as you're burning, the laser's always going to encounter the same stuff. But if you go through it with the second pass, now you've got all this char that's built up and goo, for lack of a better term for it, and it's not consistently thick. You got the air that's being blown, and it's going to push it into crevices, and it's not going to be uniform everywhere. So if you go for the second pass, the laser's not encountering uniform material, so you're going to have a non-linear cut, basically. So you're going to end up with a weirdness to it.
Okay.
Yeah.
Did you, for all of these, did you just use the same cleaning process, toothbrush, water?
Yep.
And that's how you just,
Yeah, exactly. This is all done with just toothbrush and water and a little bit of soap.
I know it's nuanced, but how did you come up with that cleaning scheme?
I mean, I Googled the whole process.
Oils or
Yeah,
solvents or-
I found on Epilog's website, they recommended using Fast Orange. So I bought some and tried it,
Yeah.
and it did not work at all. Basically, it just dissolved the goo so that instead of being tar-like, it was more like a thinner, much less viscous, and just got everywhere on the piece and stained it. So it did not help.
Yeah.
But
And this-
water, I mean, obviously the problem with using water is it raises the grain. And that's going to be a problem no matter what for this.
Just to give us a sense of magnitude, when you clean this piece up, how does it take, like a minute or 5 minutes or 10 minutes?
Good question.
Oh, maybe 5 to 10. It's not very long. I
So do
mean,
you laze for 1 minute and clean for 20?
this piece took 1738.
Dude, if you used alcohol with that too.
You probably could use alcohol, but it would need a whole lot. So if you're willing to use a bunch, then sure.
Yeah.
I didn't try it.
I was just thinking, it should raise the grain as much,
Mm-hmm.
and it should dissolve the tar pretty easily.
Yeah, certainly possible. If somebody wants to try it out, go for it.
And no tweaking on air assist volume.
No, I
Right.
used maximum air the whole time.
Okay, so trying to evacuate.
Get everything out of there.
Yes, right.
Yeah.
I had some people do some like an Indian headdress for me and some other things, and it was 3D, but what I did was I just got a block of wood and put a piece of sandpaper on it and rubbed it across back and forth, and it only highlighted certain items, but it really gave that effect because everything else stayed black. Those high raised items stayed white. It came out pretty cool. Just something to think about.
Yeah, unfortunately, the finish you get on this is super rough, and I don't know of any way you could sand this.
Yeah.
You might be able to like sandblast it and perhaps get a reasonable
Have you ever
result.
used walnut media in a sandblaster? Okay.
One thing that might help, David, and you ever want to try it, those sand mops, they have the flexible sandpaper. I use those for my 3D carvings. And the only problem is if you get too aggressive, then of course you sand away the detail. But if you used a high grit, you could at least remove some of that raising the grain. It might work.
Yeah, I mean the grain raising isn't noticeable at all in the engraved areas because they're so rough.
Right.
It's all texture. It's really just the surface around
That's
everything.
why I say like a sanding mop, just a
Yeah.
quick.
Yeah, the surface problem is not, or the area around the engraving, although it does have the grain raised, isn't an issue because that can be sanded.
Right.
I mean, as long as it's not the engraved part, you can go to town.
Right.
So that's. And here's another example. So this one is a nature scene, and it took 27 minutes. Same process, same settings as the koi scene. And this is one of the better ones. It also has the nice design feature of having a frame built in. So I was able to carve that.
David, the settings that you settled upon for the 37, do you have those saved on the machine somewhere?
No. There's on the slide. Yeah. But yeah, so this one I thought was one of the best ones. And most of that just comes down to the design being specially made to be a good carving for this style. Because you really need to have, I mean, just looking at the source, it looks contrasty. And you can see all the stuff. And if that's the case, the output's also going to be contrasty in the vertical sense. And that way you'll be able to see the pattern better. And this also has a lot of small details that have sharp transitions. And that translates incredibly well in the engraving as well. Unfortunately, so things like down here in the wood where it's a smoother gradient, I mean, you can see it when you look at it that it's smooth, but there's very little detail to see in the final output. So this is basically just an illustration of fine detail works better than coarse detail for 3D engraving with laser. And we've got these excellent, I'm going to call them dragon knots, where lots of triangles chasing each other. And this is where I did one with maple and with walnut. Not exactly the same size, and the settings are a little different, but they're pretty comparable. And I guess one thing with the walnut is that it's a coarser grain than the maple, and it's open instead of closed. And it's a lot darker. And all of that works against it, so that the pattern is harder to see in the walnut. And it's less refined. There's those. And let's see what's right. Then we've got some upholstery. So it seemed like it'd be an interesting pattern. And this is where I did another different material. So I tried it with a piece of mahogany. Well, I'm assuming it's mahogany because it's what it looks like. If somebody can correctly go for it. But this was an absolute nightmare on laser. I would totally recommend against it. It made all sorts of soot. It was just everywhere. And it didn't engrave very deep. So those are those.
My experience with mahogany on a regular car is that's good information, because my experience with mahogany on a regular car is it actually works pretty nice. You get a nice, smooth, clean engraving. I did a cribbage board for the holiday gift sale with the San Diego skyline. I did Mancala boards that were out of mahogany, and I was surprised at how pretty the engraving turned out and went nice and deep.
Was that with a laser or with a
Laser? Yeah. So I made them out of a CNC, obviously, but the logo said Mancala on top, or the city skyline and stuff. Those were done with my laser, and I had accidentally left it at a higher power than I thought I did, and I put crosshatch on it. So it was burning probably 1/8 of an inch deep. And I was impressed with how smooth the bottom, and it came out. It came out very, very nice. And so that's been my experience with mahogany. And so it's interesting when you bring up that when it was a nightmare to work in this process.
Yeah.
I don't know if that was because of the difference in radiation and changing or what, but in my case, it was a nice smooth, I wasn't trying to get the 3D effect.
Yeah, I mean, at a constant depth, I don't think you're gonna have a problem. It'll get
Yeah,
there.
that's what I was saying, constant.
It's just that if you want to have the variation, that it's not able to burn that much different.
I think that could, yeah, okay, I got that. That makes sense to me because of the way it burned nice and
It was
smooth.
more of a silhouette as opposed to
Yeah.
an image.
Yeah.
So silhouette is very contrasting.
Yeah.
Yeah, so for illustration of the difference in just experience in the machine, when you're doing the maple, there's almost no smoke. It's basically just turning everything to CO2 and water vapor. And the end result's just kind of got some goo and blackness on it, but besides that, it's good. The mahogany one, it was just shooting out soot everywhere. It was coated the piece, the laser head, tried to wipe it off, but it's all sticky too, so it's like, it was a big mess.
Oh, so you're the one that did that.
Yep.
The truth comes out.
Then we've got this guy who's a lion, and I guess one thing on here to note as you pass it around, on all the pieces that have a dark edge, I cut those on the laser as well. And this one I attempted to cut, and I don't know if it was because the piece was, since it was so narrow, it was trying to bend a bit, and that was hitting the laser badly, but it had a lot of burning on the sides that shouldn't have had. And it took like 3 passes to get it cut finally. I think it's like somewhere between 3/4 and an inch thick.
So when you were cutting these thicker ones on the laser, David, were you just using the same Z height the whole time you were cutting? You weren't like varying it?
Yeah, in fact, there's no,
Because
there's
there's
very
not
little
enough
variation
room.
possible. There's only 5 millimeters to work with
Yeah.
anyway. And if you drop it below 2 millimeters from the focus, the air assist is so powerful that it almost works like a plasma lance, where it's just abrading away the wood itself too. So it didn't work out very well. Yeah.
Can you go over that? You said when you made the subject bigger, like in the ropes, it flattened it out. So if I took this guy and then made it the size of a baseball, you wouldn't get this kind of texture, you wouldn't get this kind of depth to it?
It would be the same depth, and that's the problem, because you've made the X and Y bigger, but the Z is still the same. So
I
they'd
see.
be less tall.
I see.
Or they would look less tall. They would be physically the same height.
The
Okay.
angles would be a lot flatter.
Okay.
Yeah.
Oh, I see.
Same total depth, but
Right.
it flattens it out because it's spreading it in these directions.
So you can't tell it to do the Z axis deeper?
No, because the Z depth is totally a result of the power you're using, the speed, and the
okay.
material.
Okay, thank you.
Yeah, so that's the one parameter that you can't set. So with the CNC, you can set the Z because it's physically lowering the head down. But
Right.
with laser, you're stuck with physics. Yeah.
So the Z is basically by the color gradient, correct?
Yeah.
Right, so black, I guess, I'm assuming that's what you calibrate to be the highest depth.
Yeah, black is the deepest.
So if you start off with something that's not, the darkest is not exactly black, and you could theoretically, if you're scaling the X and Y, you could theoretically scale the pixels.
That's true, but if you don't have total black as your darkest part, then your overall depth that you're cutting is going to be lower to start out. So what I found with the maple is you can get like 5.6 millimeters deep with the settings I was using. So if you were to use not black, instead of being the 5.6, you might get 5.5 or 5.4 or something. So you're going to start out with a lower total depth.
So all the depth map pictures that you find online always have black pixels and completely white pixels, and that's the maximum range.
Yeah, usually that's how you would find them because they were designed specifically to achieve that full range.
And we do have a certain focal length with the size lens
Right.
that's in there. So changing the lens could give you a greater focal length, which would change many of these parameters too. But
Yeah, but that's a good
Yeah.
point too. In fact, if we had a 4-inch lens, 4-inch focal length lens, that should theoretically let us get significantly deeper.
yeah.
So it's
We will be taking contributions on the way out the door.
Yeah. By the way, David, just for your info, I had the same problem. I was testing out my laser at home, similar wattage or whatever, and they had advertised it as cutting 3/4 inch advertising. Well, I was putting them to the test, and I was cutting out some little cooking boards out of maple. And I was going to do the whole project on the laser versus CNC and then that to do the cutout. Well, I'm referring to your cutout here. I had an atrocious looking end going through the 3/4 inch and the cleanup and everything else I had to do. Now I have a 2-inch lens too.
Yeah.
Everything I had to do, it wasn't worth it. If I wanted to cut it out, I had to cut it out on the CNC and then do all the engraving and stuff for that thick of wood. I'm actually finding anything over about 1/4 of an inch with the lens that I have, and I don't know whether you have the same issue here. You start to get that. You can see where the focus of the lens is changing, and although it burns cleaner than that did, than the 3/4 inch. You can definitely see the incline or angle on the edge of that piece of wood.
that aspect.
1/4 inch.
Here, grab it from the other room.
Well, and have you verified perpendicularity?
Huh?
It's not acceptable, is what you're saying.
Typically, if you're trying to burn a nice straight edge, if that's what your goal is, anything over 1/4 inch with the lens that I have the 2-inch lens. I've ordered a lens kit. Did you guys order a lens kit or have it already?
No, we'll be taking contributions.
Okay, you're taking contributions, okay. But then you would need to, if you're gonna start cutting thicker material, you're gonna need a bigger.
It's optics, it's
optics.
physics, yeah.
So the thickness of material thing, here's a piece that I cut that is, I think it's
thick.
0.8 inches thick. It's huge, and it cut pretty much perfectly straight.
Wow, that's pretty good.
And you can look at the backside, and there's no cleanup on that. There was almost no smoke. It was incredible cut.
Yeah.
And it seems to do that all day. And what I found really interesting is it doesn't have the angle you would expect. I mean, you're right. I mean, from the optics of it, as you leave the focal point your power is getting spread out.
Dispersed over a wider area.
But
Did you guys see this?
that is just incredible because that doesn't show it. So I think what's happening with the lens we have is that it, and the laser itself, has an incredibly intense power distribution in the center that gets much diminished and spreads out. So even though the beam itself is spreading, the part that's actually the hottest is right in the middle, so it's very little spreading at all. So it's able to cut through the 3/4 inch maple without a problem.
Yeah, what a dramatic difference on this 3/4 inch and that other piece that we just passed through.
Yeah, that one, I don't know exactly what the problem was.
What were the settings you used on this to cut this piece?
That one was 100% at 3 millimeters or 5. I can't remember. I think it's written on the bottom.
Okay.
I guarantee it's
Yeah.
on the bottom somewhere.
Yeah.
But yeah,
He
so
always writes.
we'll get that later.
Yeah, and Travis, real quick, the British guy that talks about the laser,
Yeah.
he's got some real good tutorials and explanations of the pattern of the burns.
The word intensity
Yes.
was just being used by David.
Yeah.
What is the key factor? The higher the intensity, the narrower the beam of light. So even though you do have that focal point divergence above and below the focal point, if you have an intense beam, you're not going to end up with the same bevel. So if anybody's interested, I'm more than happy to send you a link to his
Yeah,
many videos.
he's got some
But
real
he has
good
some very good videos on
explanations,
this
yes.
topic.
So the intensity of the beam, is that a factor of the lens, the laser power you're using, combination of those things?
It's
What?
largely the laser tube itself and
Yeah.
the light it produces.
Yeah.
But I don't want to take you
Yeah.
too far off track here, so if we get back
Yeah,
to...
so going on with the depth of cut thing, so this was not 3D engraving, but since we're on the side, we'll get to it. So I wanted to see how deep it'll actually go. So I got something quite thick and made a little triangle out of it so that I could put on a laser such that the top was parallel to the bed, and then I would cut across it down its length. So that way, as the laser's going across, it's getting deeper and deeper the whole time. And at some point, you expect that it's going to stop being able to cut. So that's when I made this little guy, and it basically cut all the way through an inch deep. Pass that around.
That's pretty impressive.
It's incredible. And it was like no smoke, and it also doesn't have the spread issue. So that's maple. Maple, I found, cuts great. This, I think, is walnut, and it didn't cut anywhere near as good. It only got about a 1/2 inch, and it was struggling. So I found that if you're doing the deep cuts on these lasers, maple will do great, but everything else doesn't seem to go so well. And I think it comes down to density. So maybe the maple is just less dense than the walnut, but it didn't cut as... Yeah.
I tried cutting some 3/4 inch pine the other day, and as it happened, the grain was pretty much vertical,
Mm.
and it would cut very well through the summer wood and not through the winter wood, which you might expect that, it's denser.
Oh yeah, so that's actually another thing for the 3D engraver that I don't think I discussed here, but hardwood that's got very little variation in color of the grain works great. Softwood's going to be a nightmare. So as you found, pine in particular, the light color grain will engrave significantly deeper than the dark color, and you'll be able to see the grain in the surface of the cut.
And what about face grain versus end grain?
This was all face or side grain. I didn't try any in-grain engraving. I would expect it to work okay. I mean, in this case,
That would be it.
it should be fine. I mean, assuming you're still using maple, basically it's still encountering the same materials, just from a different angle. I don't think it would impact it.
Have you used any like white ebony for what you want to?
This was all with scraps from the scrap heap.
You want to try some white ebony?
Sure, if you got it.
Bring it on.
That sounds incredibly expensive to test with.
Yeah.
Yeah, so that's why. Then we get some more exciting things. So far, this has all been artistic stuff. I wanted to see how precise I could get it. So I wrote a Python script to generate pieces for Lego.
Hey, he started off with, I wrote a Python script. This is not for mere mortals. It's about to tell us.
Yeah, now we're getting more advanced stuff.
This is intuitively obvious to the casual observer.
Yeah, so I wrote a script that would create each of the individual pieces, and then I combined all of them together in a mosaic in Photoshop, and then engraved. And some sneaky things on here. I still wanted to use the 37% min power, but that meant I was losing the top like 1.6 millimeters of wood. So instead of doing that everywhere, I used transparency for the studs so that those would go all the way back to the original surface of the wood. So that way I can get the full 5.6 total depth of cut and use it for different features.
So the white we see there is actually the surface of the wood.
The blue.
I'm sorry, the white on the right.
Yeah.
Okay.
Yeah, so I'll pass it around here. Well, first, I wanted to show that I want to make sure they can clutch, and indeed it can.
Guys, this is amazing. This is amazing.
That's accurate.
Yeah, so I mean, it works quite nicely. Yeah, so it came out very well. I was quite happy. I was even able to model the little gaps. So the Lego pieces are incredibly precise. They make them to like micrometer precision. And the way it works out, it's 0.8 millimeters is the size between the studs. And they follow that exactly except the edges of the piece. They've got a 0.1 millimeter cutout inside on the edge of each piece so that when you put them next to each other, there's a little bit of a gap because they're perfectly the right size. You would never be able to slide them in and out.
Right.
They would just get stuck and be there all the time. So I was able to model that little gap, and as you look at the piece, you'll be able to see that, in fact, it does have those between pieces.
So how many hours did it take you to research the actual dynamics and dimensions of a Lego?
That was actually pretty easy. If you use Google, and you can find a nice diagram of here's all the values you got to use.
And how long did that take to burn? What was the total time?
I didn't actually get it. So the only way I get the time is I take a picture when it finishes the cut, and I can see on the screen. But I want to say it was on the order of like 25, 30 minutes. Not too long. And this is showing the comparison between the physical Lego.
Cool.
So the way I done this, I just found a piece of wood that was about the right size, and then I just got out a bunch of Legos and started making a thing. And I wanted to have as many different kinds of pieces on top as I could as a challenge. So I did that, and then they looked very similar. And then that
Congratulations, man. That's just amazing.
Yeah, that's showing that it clutches together and holds properly. And now we get to acrylic, another exciting material. So first we'll start with test image. And these are the same except for the line interval. So you can see that it's kind of hard to tell when you look at the physical thing, you can see it easier. This distance here is taller than here. And that's where you get the impact of changing the line interval makes it deeper. So that's the comparison between those two. And the other thing here is that it's a 1/2-inch piece of acrylic, cast acrylic. I also cut these out with laser, and that was with 100% power at 3 millimeters a second. They were great, beautiful edges. So then we've got more exciting non-test images. So here's some Mandelbrot sets. So this is also taking advantage of the fact that transparency is laser off, and with acrylic, laser off means you get a nice mirror finish that's transparent versus the engraved areas that are translucent. So this is two different takes on it to how it can be shown. The first one, I wanted to just do the different layers that you can get from Mandelbrot set. But when you look at it, it's hard to see them because with the acrylic, it's so uniform and the color is so consistent everywhere, it's hard to see the actual model inside. So then the other one I changed it so that instead of just being a step up and up, there's a gap between each one. So that way it goes back to the transparent so you can see the separation. So that way you can actually see that, this one's lower than this one and that's lower than the middle. So you get the different layers of thickness throughout it. And acrylic works nicely.
And no cleanup, right?
Good stuff. And here's a bigger one. So that's the one I've got going here. I don't really want to pass it around only because it's going to scratch easily. But it came out quite nicely as well. And that one took a 1/2 hour to burn in the laser. Yeah.
I would never use these machines if I'm new. It's okay to use acrylic and wood in both machines, or you have to have...
Yeah. Both machines can use the same materials. Acrylic is okay. Other plastics aren't. So it's very important that you pick the right kind of plastic. So for instance, polycarbonate, you can't cut in the laser. And yeah, so there's two different problems you can have with different plastics. One is that if they've got chlorine in them, like PVC, it will come out and the chlorine will destroy the lens. It will eat it, as well as all the material will get rusted. So it's a terrible thing. The other problem is it can put out hydrogen cyanide gas, and that's a little poisonous. So it's important to use acrylic and not other plastics.
The basic rule for lasers is organic materials, so from rock to paper to, not scissors, rock to paper to wood to other organic materials and acrylic. That's the basic rule to start with. And so, as he's been doing here, just have at it. It's not a problem.
Yeah. And the material that flashes off into your waste, be it wood or be it rock, it doesn't jam the machine, you're okay with that.
Yeah, the acrylic can make the cone a little bit messy, but we just have to look at it.
Yeah, I did that too.
That I knew.
Yeah, it's actually interesting when this burns, when the acrylic burns, it's also very clean. It's almost all smoke, except for like a powder of white, a very fine white powder that just kind of floats everywhere. And the next picture is showing how that works out. So this is how the smaller of the Mandelbrot was engraved. So some things here, I use wet paper towel under, and that avoids when the laser crosses the honeycomb, it gets a flare up, and that'll burn notches into the back of the acrylic. So by using a wet paper towel, you can avoid that problem. And it's important that it not be dripping. You don't want to have water in the laser bed. You just want the paper towel to be wet itself. And you definitely don't want it to be a dry paper towel. That would catch on fire.
That's a good tip.
Yeah.
And as far as the height down to Z, was there any influence on that with wet paper towel?
Well, I mean, I focus it after that.
Okay, yeah.
Yeah, so put everything in and then focus it. So that worked out fine. So this is showing how it looks straight off the laser, and you can see that it's basically clean except for white powder. And that was very easy to clean off. It just comes off with water and a toothbrush. Didn't need any soap. But what I found was that when using the 0.03 millimeter line interval, it creates like fins in the bottom, the very deepest parts. And I suspect that as it was burning, some of those were thin enough they just kind of folded over, and that trapped some of the powder underneath. So when you look through it, you can see there's like darker areas. And I found the easiest way to get rid of it was to take a stiff needle and just scrape across it and snap all the little fins off. Because they're all like sub-millimeter size, but they're big enough to hold stuff under them. So you can kind of see it down here where there's some folded over like that. So it was a little bit more involved than just using a toothbrush, but it was reasonably quick. The only real problem I found was that with the bigger Mandelbrot, I had done the cleanup and I pulled off the paper, because I mean, the acrylic all comes with a protective paper coating on both sides. So then it was, bare, perfect finished surface. And then I'm like, oh no, I've got to go in there and pick everything. So I'd be very careful to not pull up too far and scratch across the top, which did happen a few times.
So you cut the acrylic with the protective paper on both sides?
Oh yeah, you don't want to take the paper off until you're totally done with it.
Why not?
Because you can scratch it. The acrylic scratches incredibly easily. Just rubbing a paper towel across it will scratch it. The only way I found to clean it is with like a microfiber cloth. So it doesn't like anything at all.
So Peter, you care about your results.
Well, I've used a lot of acrylic, and I don't have that problem, frankly.
Hence.
All right, so then we had some wrap-up stuff here. So these are the 4 materials that I tested with. Got maple, acrylic, walnut, and mahogany. Maple was beautiful. I would definitely recommend using that. It's going to give you good results. Acrylic's also fantastic if you want to have that. It's going to be used in a different scenario than wood, I suppose, because it's transparent, so you're going to have it set up for something like that. But it works great too, because it's such a consistent material, it's going to give you the same results all the time. Walnut will engrave okay, but it will have more of an impact from the grain. It will cause more variation in the actual engraved areas. And the dark color of the walnut makes it hard to see the details of the piece. And then mahogany I found was not good. It didn't engrave very deep and it was making a mess. Yeah.
You also mentioned pine.
I didn't try it with pine, but I've
Well,
seen...
I tried it with pine, and I talked with you about it. Remember and I've got a picture if anybody wants to look at it later, but basically it's what you exactly described. So I don't know if you were describing it based on our conversation and what I did with that Proud to Be American thing that you transitioned for me. And I tried it with pine, and the challenge was just what you said. There was such a dramatic difference between where the grain was streaking through, and it wasn't. I mean, it literally rippled through the whole project. So I just wanted to add pine because you mentioned it earlier, and I tried it. It doesn't work well for 3D engraving.
Yeah, I would think so too. I wouldn't even use it for
It didn't work
black and
good
white
for engraving.
Yeah, I wouldn't use it for black and white
It didn't work good
engraving
for
either.
3D engraving especially.
Yeah. Yeah, I think it also have problems if it's particularly sappy. You want to not have any sap in there. And then here's a summary of the settings. So this has several different things. We have the most accurate, which is what I was using for most of the engravings. That's got the 37% min power. And then you have the maximum possible cut depth, which is using 4% min power. So that's where you are okay accepting some inaccuracy versus wanting to have it be as close to your 3D model as possible.
So this question was asked, I think, by you earlier.
Actually, just a question. Everybody's taking a picture of this slide. Can we make this deck available or some slides available afterwards?
Yeah, I was planning to send it out.
Excellent, great.
Well, to figure out how to compress it, this is currently like 100 megabytes.
Okay.
PDF it.
Not as big as the video, though.
You're on a roll today,
So
Paul.
I'm not sure. I think he might have asked that question, but somebody in here asked the question, are these settings in the laser? And so has any thought been given, and the answer was no, they're in your head. Has any thought been given to actually putting in the library of the laser a section 3D engraving and then just saving these files? And then those people who know how to use libraries in Lightburn would have it there for them, and those that don't, in future classes will end up with that knowledge.
We actually need to talk about what's next, and if you guys are willing to stick around for a few minutes when he's done, I'd like to explore that with you.
Okay.
This is part of what we could be doing, but if you would mind, we'll just hold off on
No,
that
that's
until-
fine. I just was asking if we give it consideration.
Yeah, I mean, that sounds feasible.
There's so many things that we're learning in these presentations, Travis, are things that it would be nice if you didn't have to remember. You could go, now that I'm learning about library public stuff, it'd be nice to just be able to go get that.
Absolutely.
The forums.
Forums,
Go to the forums.
Forums will help, but I'm talking about if it's in the machine.
He's talking about the material library
I'm
inside.
talking about
Yeah.
inside
Oh, yeah.
library.
Yeah, the one thing I'll say though with these settings is that it should be a good starting point for you, but I would definitely recommend doing test cuts on the piece you're going to use.
Well, you sound just like those YouTube guys.
Always do
This
test
is
cuts.
always a good starting point.
Don't blame David.
Yeah.
Yeah, the
Translation through Kurt.
Don't let David.
that's been like even just using just the maple, they were
There's differences, yeah.
For the engraving, it was basically fine, but for the cutting on the edges, there were differences between different pieces. And I don't know what was different. Maybe it was different humidity of the wood itself, possibly. But for the cutting specifically, you definitely want to do a test cut in some area that you get scrap on your piece. And it's easier just doing a 10 millimeter square and seeing if it'll cut out. And if it doesn't, go a little slower until you do. Because if you do the first cut on your final piece and it doesn't cut all the way through, and you move it, you're going to be real upset.
I think that's one of the hardest things I've learned over the last couple of years, because remember, I was new to woodworking. So probably a lot of these people that are seasoned woodworkers know, but especially with the laser and the CNC, because even on the CNC, you want to make test cuts to see how it's going to carve and other things. Factoring into my material selection, enough material that I wasn't trying to go cheap so that I had stuff to play with, I think is a critical factor, because I want to get as cheap as possible, so I'm going to have a piece that's just makes something up 3 by 5 inches, so I go buy something that's 3.5 by 5.5 inches. Well, now I can't test anything with the material. So if we're ever buying material, that's important. That what you just brought up is critical. That I've learned through the school hard knocks over the last few years.
Yeah, test cuts are very good.
Yeah. Well, it's anything like in the shop. You always want to get a larger hunk of wood to test out your finishes. For machining on the saws, you always want a larger hunk of wood.
Well, it seems intuitively obvious these days, but let me tell you, a few years ago that wasn't obvious to me. I was trying to cheap out.
Yeah.
And we do have people that are new to woodworking and that go to these things. So.
Just don't get cheap people.
Yeah, the one thing I'll say about the cutting of the edges, the 5 and 3 millimeters second is very slow and potentially dangerous. You want to watch that like a hawk to make sure it's not going to catch on fire. And you'll also want to, when you do your test cuts, find the speed that's as fast as possible to limit that problem that still cuts through. See, for instance, if you were doing a 1/4 inch acrylic instead of 1/2 inch, you would not want to use 3 millimeters a second. It will cut through it, but it's way too slow. Maybe get more flare from the bottom because of that. So you want to increase the speed in that case.
So what about the idea, because I see in all of your slides here, and you got experience, and Travis and others are more experienced than me. When I'm still in learning of my lasers, and using this laser, and I keep getting from the people that are telling me, like from Laguna and stuff, that they don't want me to go to 100% power except on rare circumstances. You know, they want me to run it at the lowest power with the fastest setting I can to preserve tube life, they've said, other things. Yet I see a lot of yours are 100% max power. Now my machine's already limited on how much it go out. I mean, I made a physical limitation on the machine, but they still tell me to keep it lowest power, highest burn rate. How is that? The question is, should we be going to 100% power on a regular basis, and does that do anything to the tube life?
Yeah, so just allow me so that we can get back to the presentation. We put a physical constraint, as you have on yours, to what the maximum power that the tube output is. It may well go to the 100%. We limit it to 90%. So when you in Lightburn say 100%, you're only getting 90%. So we're not actually deteriorating the bulb, and we are preserving. So you can go to 100% on these machines anytime you want.
That's the question.
That's the one. Yes.
Yes, basically, there's 2 different percentages. There's the percentage that Lightburn has,
Right.
and there's a percentage on the controller on the laser itself. So we have set it so that 100% in Lightburn maps to 90% on the laser itself. And the user doesn't think about it. It just works.
Sure.
And it's always going to be a limitation you don't have to think about. So.
Yeah, that was really the crux of my question. Is going to 100% on a regular basis on our machines okay?
Yes.
The answer is yes.
Yes.
Going back to the material flaring up and actually catching on fire, as long as we're talking about it and anticipating we might have more incidents of that as a result of experimenting with this.
Yes.
What is the recommended procedure for putting out a fire if you catch material on fire?
Run like that.
Yeah,
Oh,
besides.
Besides, because I let the building burn.
So the 3 steps that we teach are when something simple happens, you simply pause your job, don't stop your job, pause your job so you can start where you were. Lean in, blow it out. If it's just a small flame, that should be fine. Second is you can simply cover the material and it should smother it. And lastly, we have on the wall in there a type of fire suppressant which doesn't put white powder into the machine. It just gets rid of the oxygen. I think it's halogen.
Metal extinguisher, is it a hand extinguisher?
Yes.
Halon.
Oh, halon. You got a halon system back there?
Yeah, it's just a small extinguisher about
That's
that.
expensive.
It is, but you don't want to have to, imagine having to clean the laser after you've filled it with white powder. That's what makes it look
No,
wild.
you don't want to set up a dry
In
can.
the 5 years, we've never had to use it, so it's actually a very good investment. But that's the third thing, the extinguisher in there in the event of fire. Great question.
Yeah, the other thing I noticed too is that the air assist will cause the fire to keep burning more. So
by
hitting pause, you can be perfect.
Does the air assist
No,
turn
air assist
off?
doesn't turn off when you
I was
hit
going to say, it
pause.
doesn't turn off when you hit pause.
No, the only way to do that is to
Lift
cancel the
the-
job and then move it with the buttons.
On these machines, you do have a variable control on the left-hand side where you can adjust the air assist flow between a high power and a low power, and even within those high and low, you can turn it more or less. So there is a way to vary the air assist once it's started. Yes, Pat, go ahead.
You might want to remind them also of the flame picked up on the gantry.
Yeah, there is a fire detection system in the laser.
Oh, there is?
Oh, really?
Yes, it is a metal plate that's under the gantry, if you take a look at it, and that would detect the heat of a flame and either turn the laser off or kill the machine.
Cool.
That's amazing.
But don't let it get to that.
Don't test
I
it.
think if it's that high, you're already going to damage the machine.
Yeah, because it's probably 5 inches-ish off the work surface is where that detection plate is, so.
So Dick, why don't you go ahead and finish up?
Yeah, I think there's just one more slide, or 2 more slides.
Oh, this is, this is.
Yeah, so here's playing the block is we're asking about. How do you get the depth map images? So the very easiest way is to go to Google image search, you search for grayscale depth map, and you're going to get a page full of results. And most of them will be okay. The problem is that there's some general 3D models that were just like a physical object that somebody had 3D scanned and made it a great depth map image. But the problem there is that that physical object had significant depth to it, several inches, say. But when you engrave it, you're only going to get 3 millimeters if you use the 37% or 5.6 for the full range. So it's really thin. So if you try and burn that, it's going to look like basically a flat plane. And the easiest way to tell if it's going to look good when you engrave is if it looks contrasted. So if you look at it, you can see the pattern really well. It's probably going to engrave well. If you want to be more adventurous and figure out your own design instead of downloading one, you can create one from a 3D model. And I found 2 ways to do it. The original one is what I found years ago. And it's pretty fiddly. I would not recommend it. The much easier option is to use this STL to PNG website. And it's a JavaScript app, effectively. Runs in your browser, and you don't have to install anything. And although it's a website, all the data processing is local on your machine, so you don't have to wait for it to upload or anything. So even if you've got a huge file, it still won't take place. It won't take any time to upload. And that works fine. But you have to keep in mind the same problem with the 3D model is that the model needs to have been designed with very little thickness in mind. If you just got a random object, it's not going to give you a good result. You have to find something that somebody designed like as an engraving, like a bas relief or something. That'll work out fine. And then the way you can verify if a given depth map is going to give you a good result is by converting it back to a 3D model. And this script will do it. It requires you to at least have Java on your computer. And this worked out great when I was doing some slight modifications on the depth map. So for instance, in Photoshop, you can go through and increase the contrast on the image, and it'll make it look sharper and more contrasty, and then that will translate into more depth difference in the final output. But when I did that, I wanted to make sure it was going to look right before I cut it, so then I converted it back to a 3D model, and I opened it in VCarve because it was convenient, and just changed the Z depth to be, 3 millimeters. And that way I could see if it looked right. And that worked out fine.
I will say when I was asking you a question, David, you'd mentioned just go to Blender and do this stuff. Unless you're a computer geek, somebody that's really into programming and understands how 3D models and imaging and all that works together, if you go there, it will hurt your head. and you'll walk away after an hour of reading stuff that you didn't understand, saying, what the heck did I go here for?
Yeah, unfortunately.
So and he just mentioned that, but I just want to say, I think that's a great place. If you're into computers and imaging software and you have a good fundamental understanding of how all that stuff ties together, I think you'd go there and you'd understand. If not, you're going to go there and be ready my point is, don't give up like I did. I gave him a call, David, and he said, I'll convert it for you. But
Is that a service, David?
no, I don't think he does that. He just is trying to get me off his back. But what I'm pointing out is just be ready to be patient about working your way through that first converted an existing to a depth map.
And
Yeah,
start
not easy.
simple.
Huh?
Start real simple.
Yeah, that's-
Baby steps.
yeah,
Real
it's-
important.
It was,
Yeah.
it made me cry.
Yeah.
Unfortunately, when I give you the instructions, I give you the mesh lab instructions.
Yeah,
Because that's what I had originally found when you just search for it on Google. But after that, for this presentation, I searched a lot deeper and
I'm gonna
eventually
try this
found
one.
this STL to PNG. It's like, oh my God, this is exactly what we want. It's literally as simple as you go to the page, there's a box for the resolution you want, you just tell it how many pixels wide,
Okay.
and there's a button to load your file, and then it just gives you the output. So there's no extra steps, it's super simple.
Very good.
Definitely recommend that. And any more questions on this part? All right, final slide. So the Nova 51 we were asking about, and the reason I didn't use it for any of my testing was it has this vertical ripple issue, and you noticed it immediately when I sent the piece around. But one of the pieces that went around is this one that shows this ripple, and I don't know exactly what causes it. I suspect it's the same problem the old blue laser had, because it also showed this vertical pattern. And I had spent a lot of time on that trying to fix it, and couldn't make it happen. So if somebody wants to take it upon themselves to figure out how to make the Nova 51 give good engraving results, go for it. I did not like it.
Is the tube elderly?
No, these are both brand new.
Yeah,
Super brand new. So, yeah, that was a weird effect. I don't know what's causing it, but I didn't want to use it for testing because of that. But it's something to keep in mind. I suspect you'd have the same problem for other types of engraving. It might leave a pattern. Even if you want a flat bottom, you might still see the undulations. But I didn't try that.
I'm not clear, which is the Nova 51?
The big one.
The big one.
The big one?
Yeah, think in terms of 51 inches wide versus 35 inches wide.
Oh. So what machine were you doing all the nice ones?
It's smaller than 35.
Oh, the 30. So that's it.
Yeah. Yeah, which is somewhat disappointing because the 51 has a 130 watt tube in it. So that should be able to engrave deeper. So I wanted to use it for that reason. But then I saw this pattern being put into it and I was like, well, I guess I'm sticking with 35.
How many watts is 35?
100 watt. Yeah, there was some speculation that perhaps the belt on the 51 was looser and that was causing some weird oscillation of the supply across, but I didn't have time to figure that out. I already put 8 shop slots into this project, so.
David, we can give you those shop slots.
I hope those shop slots aren't going to
The
get
cheapest
short.
payment for an incredible presentation.
Yeah.
Seriously.
Yes.
Yeah.
All right.
Absolutely.
Thank you. Yeah.